Hello guys, welcome everyone. This is Nathan, USN1V 20CS106, and I'm from 6th Sem Bhaskara section, pursuing CSA in SVC. So my today's topic is about the subject non-conventional energy sources. Code is 18ME651, and the topic about today's video is flat plate collectors. So let's not waste any time. Let's get started. So at first we have the introduction. So solar thermal collectors. A solar thermal collector are special kind of heat exchangers that transform solar radiation energy to the internal energy of the transport medium. So the major component of any solar system is the solar collector. So solar collector is a major component in any solar energy systems. So let's get on to the next slide. Now we have the solar collector. So we have a definition for it. Collector is a device which absorbs the incoming radiation, converts it into heat, and transfers this heat to a fluid flowing through the collector. So this is collected. So the solar energy thus collected is carried from the circulating fluid either directly to the hot water or space conditioning equipment or a thermal energy storage tank from which can be drawn for use at night or cloudy days. So this is the definition of a solar collector. So there are many types of solar thermal collectors. The solar collectors are either non-concentrating or concentrating. So in the non-concentrating type, the are the area is the same as the observer area. In these types, the whole solar panel absorbs light. So concentrating collectors have a bigger interceptor than collectors. So for domestic or industrial water heating and space heating purpose, the solar thermal collectors are classified as flat plate collectors, evacuated tube solar collectors. So these are the two types of collectors that have been classified in domestic uses as well as industrial water heating and space heating purposes. So let's move on to the next slide. So we have the flat plate collector. So what is it and how does it work? So a solar flat plate collector has an absorber plate, a diffuse radiation, and a direct radiation received from the sun. And there are tubes, they are called absorbent tubes. So this is basically a diagrammatic representation of a flat plate collector. So now we have a flat plate solar collector. So what is a flat plate solar collectors and when what was developed? So the flat plate collectors developed by Hotel and Villiers in the 1950s are the most common type of solar collectors which are widely used for domestic household hot water heating and space heating. So where the demand temperature is low, flat plate collector is basically a blank surface that is placed at a convenient path of the sun. So this is how the flat plate collectors are used. So now the components of a solar flat plate collector. Any device must have some specific set of components to make it work. So solar flat plate collector have some components. They have a flat plate absorber, the transparent cover that reduces heat losses called gauging, a heat transport fluid, air, antifreeze or water to remove heat from the absorber, a heat insulated packing, flow passage, and an enclosure. So these are the components of the solar flat plate collector. So this is another diagrammatic cross-sectional view of the solar flat plate collector. So here see we have a black plate, we have a black plate here, and we have an insulation above it, and then we have tubes, that is header tubes as well as the absorber tubes. So above that there is a gauging area and the risers. So these are the components in a cross-sectional view of the solar flat plate collector. So now we are going to each one of the components, that is now the absorber plate. So absorber plate, it is usually made up of copper, steel or plastic. The surface is covered with a flat black material of high absorbance, and if copper or steel is used, it is possible to apply a selective coating that maximizes the absorbance of the solar energy and minimizes the radiation emitted by the plate. So next, the flow passages. The flow passages conduct the working fluid through the collector. If If the working fluid is a liquid, the flow passage is usually a tube that is attached to or is a part of the absorber plate. If the working fluid is air, the flow passage should be below the absorber plate to minimize heat losses. So this is about absorber plate as well as flow passages. Then we have the cover plate. To reduce convective and radiative heat losses from the absorber, one or two transparent covers are generally placed above the absorber plate, so they usually be made from glass or plastic. Then we have the insulation. So there are many some materials such as fiberglass, and they are placed at the back and sides of the collector to reduce heat losses. So the heat must be trapped inside the collector to increase its efficiency. Then we have the enclosure. So a box that the collector is enclosed in holds the components together, protect them from weather, facilitates installation of the collector on a roof or appropriate frame. So this is an enclosure. Then we have typical diagrams of flat plate solar thermal collectors. So here that is the coolant inlet, the solar radiation are being absorbed, the coolant outlet, there's a frame, there's a flow tube where the energy transferring medium of the fluid that basically transfers the heat, absorbing plate insulation as well as the glass that intakes the radiations. So it is a typical diagram of the flat plate solar thermal collectors. So let's move on to the next one. Working principle of the flat plate collectors. In a flat plate collector, sunlight passes through the casing and strikes the absorber plate, which heats up, changing solar energy into the heat energy. Thus, the heat is transferred to the fluid, any fluid inside those absorbing holes. So, passing through the pipes attached to the absorber plate by the means of a convective heat transfer. So, absorber plates are commonly painted with selective coatings because it needs to absorb the solar radiation, so which absorb and retain heat better than an ordinary black paint. So, this is the working of flat plate collectors. So, as absorber plates are usually made up of typically copper or aluminum because the metal is a good heat conductor. The copper is more expensive, but it is a better conductor and less prone to corrosion than aluminum. In locations with average available solar energy, flatbed collectors are sized approximately 1/2 to 1 square foot per gallon of the 1 day's hot water use. So now we have the applications. Flatbed collectors are used for both domestic as well as commercial applications. Domestic applications like flatbed collectors are used mainly in residential buildings to demand for hot water has a large impact on energy bills, and for instance, a family of 4 members consumes an average of 100 liters of hot water a day at 60 degrees Celsius. Hot water of 100-liter capacity at 60 degrees Celsius approximate can be delivered by a single collector system of 2 n square area. So this is what a large supply of hot water can be done by using solar flat plate collectors. So this is a flat plate collector installed above the rooftops of the house for the hot water purpose. And commercial applications include laundromats, car washes, military laundry facilities, and eating establishments. Solar water heating systems are most likely to be cost effective for facilities with water heating systems that are expensive to operate. So the operations such as laundries or kitchens that require a large quantities of hot water. So, and unglazed liquid collectors are commonly used to heat water from for swimming pools. Because these collectors need not withstand high temperature, they can use less expensive materials such as plastic or rubber. They also do not require freeze proofing because swimming pools are generally used only in warm weather or can be drained easily during cold weather. So this is used in swimming pools as well. This is just a view of the system used in swimming pools. Now on to next, we have the conclusion. So flat collectors which are used for water heating are long lasting, and also in long term they are cheaper than other water heating systems. However, they require a large area if the high energy output is requirement. Also, solar energy is free if we do not include the initial cost for installation and the maintenance. So finally, besides these, we should remember by using solar energy we can basically protect nature. It is a green energy, not causing any pollution with utilizing the solar energy. So that's what it is friendly. Thank you guys. Thank you everyone spending your time on this video. And this is Nitin, and I'm signing off, and have a great day.